Assalamualaikum warahmatullahi wabarakatuh. We're from Group 3 and today I want to present about Water System Design Management project. So first I want to introduce myself first. My name is Farwaini binti Muhammad Ismail and my matric number is DF200-134. As we know, water is crucial for living things, and absolutely necessary for all living things. So water is crucial for the community since it will be used for cooking, bathing, flushing, toilet and so on. For the industry and agriculture, the water also need to be easy access. So in this project, the architecture drawing of area residential has been required. So the area of this project, which is 70 hectare. So it is located at Taman Desa Wira, Sungai Semberong, Johor, Malaysia. So this area is residential area that consists mixed development such as terrace house, bungalow and semi-detached house. And the use of water at this area is high because since there are many population live here. So water is basic resource for human to survive, so therefore it is important to consider the water management at this area in order to provide comfortable living space for the residents at Taman Desa Wira, Sungai Semberong. For the objective, first is to determine the water demand based on the population of the residential Taman Desa Wira, Sungai Semberong. And for the second one is to determine the size and design sewerage for the residential at Taman Desa Wira, Sungai Semberong. And the last one for objective for our project, which is to determine the stormwater management for the residential at Taman Desa Wira, Sungai Semberong.
Assalamualaikum, my name is Muhammad Daniel Izzuan bin Ahmad Fairuz, and now I will continue the presentation for the methodology. So as we can see, this is our flowchart for the methodology, and the process start with the find the site area of study. Next is collect the data for the information, and after that we will generate architectural drawing of the area. And the last one is analyze the data for the water reticulation, water sewerage, and stormwater management. Okay, next, this is our layout or architectural drawing for the area that we choose. So this plan consists of three type of houses, which is semi-detached, bungalow and terrace.
Hi, my name is Muhammad Syami bin Osman, and now I want to talk for the discussion. So for the part 1, which is the water reticulation system. So here is our water distribution layout and the specification. The layout is on the left hand side and then the specification is on the right hand side. For our pipe, the diameter is 0.2 meter. The roughness coefficient, which is C, is used by us is 140, and then the assumption pipe length there are two, which is 82 meter and 54 meter. Next is water demand calculation. So there is 3 type of unit that we use. The first one is terrace, second one is semi-D, and then the last one is bungalow. So for the calculation, the unit of terrace will be times up with the average daily water demand, and then we plus with 14 unit times 2000, and then the bungalow will plus with 10 times 2000. So and then we get the water demand calculation value is 76,600 liter per day. So here is the table that we use to calculate the water demand calculation. So there is 3 units that we use. The first one is the terrace house, the single story terrace house, which is the average daily water demand is 1,300 per unit. Then semi-detached house, which is 2,000 per unit, and then lastly the bungalow, 2,000 per unit. The next calculation is the peak flow and fire flow. For the peak flow, the formula is 2.5 will times with total water demand that we get, which is 76,600, and then we get 191,500 liter per day. And then the next one is the fire flow, which is the total water demand value, which is 76,600 we plus with the fire risk, and then we will get 1,718,200. From two value, we need to choose the highest one, so we choose peak flow as our Q. So this is our proposed layout, where is the flow in is the 191,500, which is at the C0. So this is the checking analysis. There is two loop that we use. So the difference of the Q correction, which is negative 0.0003 for loop 1 and loop 2, is acceptable. So there is no extra trial. So there is no extra trial is needed. And then this one is the adjustment for Q final. For the CA pipe, the final flow is 0.004. For CD, the final flow is 0.007. AB is 0.0001. BD negative 0.001. CE 0.0010. CD is 0.007. EF 0.007, and lastly FD, the Q final is 0.005 meter cube per second. So here is the figure for the layout after the correction. The left one we use the flow, and then the right one we use the head loss or friction factor.
Hi, my name is Adi Musakim. I will continue the presentation from Shahmi that calculate the water reticulation calculation. I will continue to propose elevated water tank design. First, we got the total daily demand at 191,500 liter per day. So we convert it to 1915 meter cube. Then we propose the elevated tank design that use cylinder. So from ground it use 20 meter, and the tank that we use is 10 meter. So we use the formula of cylinder, and we got the volume of design water tank is 2250 meter cube. It then bigger than volume required, so that is 1915 meter cube. So it is okay. Next, we will also calculate the residual head for our location. That we will use every single node A, B, C, D, E, F. So the elevation that we got, we list it there, and the height and TWL. So the formula is elevation plus H and minus the TWL that we got the residual head. The residual head that all nodes exceeds 7.6 meter. So the design is okay. Next, we also calculate the highest supply level at every node. It also same use as node A, B, C, D, E, F. The elevation we list that also same. The height, and but this is use HSL, that highest supply level. So the answer is at the end. The highest supply level at all nodes exceeds 0, so design is okay. So last but not least, we propose water tank on the layout. So there is on the X location is the water tank, and we put the flow water reticulation on our residential to see it.
Analysis and design of water sewerage system. Okay, for the first step is analysis and design of the water sewerage system, which is the plan has 46 units of houses, and we want to calculate the PE, which is the 46 units times 5 PE, which is the SEMIDI PE, and equal to 230. And the STP is classified as the class 1, and from the table of the land area requirement, we need STP development is 430 meter per day. Okay, next step is the purpose of the site of sewage treatment plant area model. This remark is the recommend for build in the sewage treatment plant which with the minimum 40 meter distance of the buffer zone. Next is the calculation of the hydraulic flow and the peak flow. From the calculation, we got the hydraulic flow is 0.0006 meter cube per second, and the peak factor is 5.52. Peak flow is 0.0033 meter cube per second, which is not more than 4 meter than m cube per second, which is okay. Next is design of the gravity of the sewer. Okay, we assume that the pipe material is the concrete pipe, which is the culvert. The size diameter is 250 mm, and the depth of soil cover is 1.5 meter. And to consider the 48 meter section of the drainage pipe has fall of 0.6 meters, which is therefore the gradient slope is 0.005, which equal to 1 per 200. Okay, from as we know, we choose the concrete pipe. So for the main equation for the concrete pipe is for good condition is 0.012. Okay, the next step is we need to design the half full pipe. Okay, from the area we got to 24,543.69 mm cube. From the weighted perimeter, we got 392.69 hydraulic radius, which is RH or equal to area divided by weighted perimeter, which is we got 62.5 millimeter. And the velocity we got 1.467 ms. Which is the velocity is bigger than the 0.8, which is the sediment cleansing velocity. So the sediment in the pipe will be removed, and we assume the flow is uniform. The capacity of the flow when this pipe is flowing half full is Q we got 0.036 meter cube per second. Okay, next for the full pipe. Okay, we got the area 49,087.39 millimeter cube. And weighted perimeter we got 785.40 millimeter. Hydraulic radius we got 62.5. And knowing that we got the meaning equation is 0.012, so the velocity we calculate, we got 1.467, which is average, and it is okay. So for the Q we got 0.0722 m cube per second. Okay, next for the sewerage reticulation design, which is the sewer. We assume the sewer diameter is 250, slope gradient 1 per 2000, ground level to 25 meter, upper invert level 22, and the PE in every MH is 20. As they calculate, we got 230. Okay, this is the proposed design. So we got we calculate the manhole 1 and 2 manhole 3. Okay, this is the calculation. And next, and lastly for the manhole 3 to manhole 4, until the manhole 4 to the sewerage treatment plant, we got the final DSTP is 5.15 meter, and the IL is 18.05.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Adira Iliani Bendrani and my matrix number is DF200149. I will present about the calculation of storm management. As you know, the type of our area is mixed development, which consists of terrace house, bungalow and semi-detached. To calculate this, firstly, we need to determine the design area, which we assume it 10 years. The area of the project is 70 hectares. Then we find the coefficient average by using the formula C times A over cumulative area, and the answer is 0.71. Next, we need to calculate the time concentration, which is TC. TC is equal to T0 plus TD, and the formula T naught and TD is stated in table 2.1 MASMA. So we get 0.25 hour. Then we calculate the rainfall intensity at Sungai Semrong, Johor, and we can refer all the data in table 2.B1 MASMA. So we get 183.94 millimeter per hour. We calculate the Q peak equal to CIA over 360, and we got 6.17 meter cube per second. Lastly, we calculate the Q design, which is QD equal to 1 over n A R to the power of 2 over 3 S to the power 1 over 2. The answer of QD is 45.46 meter cube per second. We got QD more than Q peak, so it is okay.
Okay, I will continue the conclusion of our project. A greater emphasis has been placed on advanced improvement when we got the calculated wastewater treatment system as an alternative for addition to improved facilities due to the expanding population, aging infrastructure, and increased demand for clean water. Last but not least, the life cycle assessment of wastewater treatment system could be used as a tool to gather important data, identify the obstacles, and learn crucial details about choosing, obtaining permission for, and putting in place improved system from subject matter experts. That's all from us, Group 3. Thank you.